the present value of the coupons is found from the annuity formula. So that will be $100 coupons divided by 0.10, which is the rate of discount, into 1 minus 1.10 to the power 10, and that turns out to be $614.46. So the price of the bond will be the value of the coupons plus the value of the face. So you add these and the price turns out to be $1,000. Now that's not a coincidence. The fact is that if the coupon rate equals the required rate of return, then the face value equals price. Why is that? Well, if you pay the face value to buy the bond, then the coupon payments meet your required rate of return. So if you are thinking of the price that you paid as the principal that you paid, as the money that you invested, the coupon payments meet your required rate of return, and at the last period when the bond face value is paid back to you, it is as if the loan has been paid back to you. So the principal amount does not increase through time because the coupon payments equal the interest rate required, and at the last period the face value is paid back, which is your unchanged principal. So your investment is paid off at the required rate of return. So the face value equaling price works if the coupon rate equals the required rate of return, the yield to maturity. Now suppose the market's required rate of return is 12%. In that case, the value of face will be $1,000 divided by 1.12 to the power 10. That will equal 321.97, and the present value of the coupons would be $100, it's an annuity, divided by 0.12, which is the discount rate, 1 minus 1.12 to the power 10, and that will equal 565.02. So the present value of the annuity of coupons is $565.02. The present value of the face is $321.97. You add them and you get $886.99. So what happened here? Well, suppose you are paying $1,000 for it, and when the required rate of return was 10%, your required rate of return was being met. But now the required rate of return has increased to 12%. Now when it has increased, what happens to the bond? If the market's required rate of return increases, does the firm also start paying more on the bond? The answer is no. The firm maintains the cash flows. The cash flows for this bond have been given as each year $100 and on the 10th year $1,100. So when the rate of return was, required rate of return was 10%, the price of this was 1,000. When the required rate of return went up to 12%, did these cash flows change? No, the cash flows did not change, because that is the bond contract. Whoever owns the financial asset is going to get these payments contractually, unless it's a floating rate bond, which it is not. We are just talking about bonds with fixed payments right now. Later we shall consider other kinds of bonds. So if the rate of return has gone up to 12% and the cash flows have not changed, how is this bond going to produce a 12% return? Well, what's going to happen is that its price is going to fall. As its price falls, the investment that you have to make to buy this bond decreases. The cash that you get from it remains the same, hence your rate of return goes up. So an increase in the yield to maturity for bonds when the cash flows to the bonds remain the same results in a fall in the price of the bond. Another way you can think of it is that you have this bond, you bought it for 1,000 when the rate of return was 1,000, and now you're trying to sell it, and let's say I'm the buyer and you're trying to sell it to me for 1,000. I'll say, if I buy it from you for 1,000, it's going to give me 10% rate of return, and I need 12% because in the market the rate of return right now is 12%. I can go out and buy some other bond of similar riskiness and get a 12% rate of return. So I don't like this bond which is giving a 10% rate of return, and the way I'm going to buy it from you is if you drop the price. So it has to be made attractive to me by having its price decreased to the point where it produces a 12% rate of return. So an increase in yield to maturity results in a fall in the price of bonds. Now this is an important point because it may seem to you that because yield to maturity has gone up, that is the rate of returns on bonds has gone up, bonds have become more attractive assets, and maybe therefore they should be paid a higher price. No, it does not work that way because the cash flows for the bonds remain the same. So an increase in the rate of return simply means that the price has to fall. So this is important to understand, that an increase in the rate of return on bonds does not increase in their becoming more attractive and the price increasing. What it means is that their price has to fall for them to produce the higher rate of return. Similarly, if the required rate of return falls, then as the cash flows remain the same, the price of the bond is going to go up. So here we have the market's rate of return going to 8%. The present value of face becomes $1,000 upon 1.08 to the power 10. So that is $463.19. The present value of the coupons becomes $100 divided by 0.08 into 1 minus 1.08 to the power 10, which equals $671 and 1 cent. So you add these up, you get the value for the bond to be $1,134.20. You see, when the discount rate has fallen, the cash flows to the bonds have remained the same. So how is it that these cash flows are now producing a lower rate of return? Because the price being paid for these cash flows has increased. It has increased to 1134.20. Or if you had this bond and you had purchased it for 1,000 when the rate of return was 10%, and now you're selling it to me, I will be ready to give you a higher price because my required rate of return is only 8%. So these statements about bond pricing are always true. Bond prices rise with falling market interest rates and fall with rising market interest rates. The reason being that the coupon payments to a bond and the face value payment does not change as the market rates of return changes. So the way the rate of return for this asset changes is by adjusting the price.